Hi guys, welcome. In this video what we are going to learn is about ipv6 ospf. Okay, we will learn a little bit about ipv6, how to configure on Cisco router, and also we will learn about the ospf, how to configure ipv6 ospf v3. So these are the three routers we have taken for this lab, and we will both all are connected via switch. Now we will start up this routers, yes. So it should be coming up, and we will look for the interfaces. Where is the interfaces for this? Is we'll open up. Sorry, we can open up the interfaces. Connect, control, view, control, console connect to all nodes. So you should be getting all the nodes are coming up. We don't need a switch with the interface, we will just need three routers. How to configure? So let's take up this router, and R1, R2 and R3, still they are coming up. Okay guys, now all the three routers are up and running now, and we will go to the console of R1. Just click on this R1. I have a console for this R1. This is the router 1 console, so we can do the configuration. I just have the configuration already built so that I can cut and paste, no need to spend time on writing the commands. So the first configuration for router 1 is just enable command config t hostname, and I am configuring a loopback address. Then I am enabling ipv6 unicast routing. Then I am configuring ipv6 router ospf process id 1, and I am setting up the router id inside the ospf process as 1.1.1. Then after that I am enabling the interface no shut gigabit interface. Then I am just creating a virtual interface on this gigabit interface with 1/0.12, and I am assigning a VLAN of 12.1q encapsulation, and I assign an IP address for this network as 2001 ABCD 123412::1 for this interface, and I also enable ipv6 ospf1 on area 0 on this interface, and exit and save. So I just cut and paste this command so that router 1 is configured with the ospf for this lab. So let's open up the DNS3. No, just we need to open up the console. Let me copy this configuration. Yeah, copy, and then paste it on the interface. Yes. So the router 1 is configured now. You can, if you have a doubt, you can just check enable show IP v6 interface. So you see a lot of okay, show ipv6 interface brief, so that you can see that brief of the interface. Yeah, it's there. You can see that ipv6 interface is created, and then IP address is assigned. If you want to look at the ipv4 interface, show IP interface brief, it will show you the ipv4 interface. Loopback interface is created, and the IP is assigned. So now let's look for the router 2 configuration, which I already also built for that. So I will show you the configuration. It's the same as router 1, but it has got two interfaces. That's why you will see that config t router hostname, and I am configuring the loopback address as 2.2, and unicast routing is enabled, and you have the IP ospf ipv6 is enabled, and router id I am setting for ipv6 as 2.2, and then interface gigabit interface is shut, no shut, and then I am creating a 2 virtual interface with the .1q encapsulation of 1.2, that is, it will be connected to the router 1, and this is the interface between round. So I just assume the VLAN value 12, and ipv6 address is this, and area 0. And what I am doing is I am creating another virtual interface on the same that is dot 23, and since for the naming convention I am mapping the same dot 23, it can be any number virtual interface, but I just want to match for easy remembering purpose. Encapsulation is dot 1q23, and I am assigning IPv6 address on this as another subnet, that is basically 23. You see here 213 is 23 on this subnet, just to match the setup to have easy to remember. That's the only reason. You can have any numbers, and the IP address is 2, router 2 I always put the interface IPs are 2 for all the interfaces, but you see this is the interface 1 and 2, between 1 and 2, and I put the IP address, since it is on the router 2 it is 2, this, but network is different network. So exit, and I am going to add it in area 1. This is an IPv6 ospf area 1, and then exit. That's it. See, this one is at area 0, this interface is on the other one, and this is interface is on the another network, so that is why it's area 1. So let's cut and paste this command so that router 2 is configured. Copy this command and then paste it on the console of router 2. Let's open up and say no here. Router 2 is up, or I don't see. This is not the. Let me check interfaces. Auto bytes boot flash cache. Oh, okay. Time right. Okay, now I'm just going to paste this command to be able to get configured. Yes, router 2 is configured. See, you can see also ospf was loading immediately after the configuration was done. It's trying to establish ospf is enabled with the router 1. Okay, it's done now, and if you want to verify, you can do some verification here also. And the same like show ipv6 v6 interface brief. All the IPv6 interface is shown here. You see there are two interfaces here, virtual interfaces created on this 1, 2 and 2, 3, and the different IP addresses. See here, that's right. And show IPv6 ospf neighbor. If you want to look, you should have formed a neighbor with the router 1, because it's and you see that it is full and DR. It is the DR is the other router, and you can check more commands on this router. After that, show IPv6, show IPv6 route, IPv6 routes. What are the routes available? Show IPv6 ospf route means it will only show ospf route. Anything like that. Show IPv6. IPv6. Show v6 route. Okay. So IPv6 ospf. Okay, we can look for the interfaces area 0 and area 1. Okay, two interfaces. Okay, let's configure the router 3 also. And router 3 also similar commands. That's only one interface, and you have it's enable config t, and then loopback interface is created, unicast routing enabled, and you have the router ID is enabled, ospf IPv6 router ospf process is enabled, and router ID for this is 3.3. And then I am just setting up the interface. Physical interface is no shutdown, and then after that I am creating a virtual interface. I am just putting dot 23 because just to remember this interface is connecting between router 2 and 3, and is dot 1q encapsulation. Since it's a virtual interface, I am assigning 23 and IPv6 and ospf, and it is in area 1. This interface is in area 1 and exit. So let me cut and paste this configuration on R3, copy and paste it on R3. R3 is here. So let me bring up this screen here and just paste this configuration. Done. So R3 is also done now. So it's again it's loading up, and it's forming the neighborship. Show IPv6 IPv6 neighbor. If you see, let's see, the neighborship is formed. Show IPv6 ospf neighbor. Show IPv6 ospf neighbor. So you see, it has a form a neighborship with the 2.2.2. It's a form a neighborship with the 0.23 full DR. And let's look on the R3. I think there is a mistake here. I just now realized. Config key hostname R3 should be R3. Okay, so it's a mistake here. Just R3. Okay, so do right, save it, exit. Okay, if you look at R2, show IPv6 ospf neighbor, just see here, you will see the two neighborship, that is between router 1.1 and router 3.3.3, that is there is a neighborship formed on the interface. So we can see that this is 3.3.3 is a BDR because, see, as per the ospf, it is the lowest IP address. Loopback interface address is 1.1.1. So router 1, so that has become a DR, and router 2 is for that it is a BDR. But in this case, router 2 is router ID is 2.2.2, but router 3 is 3.3.3. That has become a BDR. The lowest IP address is 2.2.2. It is DR. If you want to know, show IPv6 ospf interface. If you look at this, you can see what are the DRs and BDRs. Between 223, you can see who is the DR here, right? So you can see hello and DR. Designated router is 2.2.2 and backup designated router is 3.3.3. So this is how it's determined who is the DR and BDR. If you look at the other one, DR is 1.1 and BDR is this. And also you may be knowing hello time, dead time for and wait time and all these parameters for ospf. So it's done now, and just we will do some commands and then we will go to the next step. So what are the commands in IPv6? That is, you know that this IP show IP interface brief, that is IPv4 command, and equivalent is IPv6 this, and show IPv6 ospf route. We will do this one, show IPv6 ospf route. So you should be there is a wrong in this command, show IPv6 route, I think, or ospf route. Show IPv6 route. So in this one we can see that local, and this one I think there is only a command called show IPv6 route. So like IPv4 route, we will just have IPv6 route. We will just run this command on the router R3 and just check what are the routes available. So you can see that OI is that is other area, that is OI is inter area route. ospf, O stands for ospf, and OI means ospf inter area route, that is learned from through ospf. This one, and to inter area route, this is the one, this is the destination. We have to go via this interface. Via this you can reach this destination. So that is a good thing here, and these are all connected routes. So we can also check on router 1, the same thing should be applicable, because to reach the other area it should have the route here. Now let me enable show IPv6 route. Yes, you see here OI, ospf inter area route, and it is the destination is this, and if you want to reach, you have to go via this interface, right? Now let me do a ping on this. IPv6 address and check whether we are able to reach ping IPv6 and ping this address which is on the to the 123. I'll just put this paste 1, right? Sorry, the interface is 3 or on the router 3. Okay, let me ping this one 23.3. Ping IPv6 23.3. Yeah, success. You can see repeat RE repeat 10. Good. So we are able to ping from router 1 to router 3. That is how the IPv6. Same thing you can check whether you can ping from router R3 to router 1. Okay, let me also show you something on the GNS3. We can just capture the packets. So let me capture the packets going on this one. Then we'll start the capture and we'll see what is the things moving between these routers. I will be later, and I can show you that we have packets moving here between these two routers, and it should be FF02. If you look at this, this is the ospf hello packets. Okay, it is the ospf hello packets which is exchanged between the routers. You can see that both routers will be sending this ospf hello packet. See, you can 63 and 64 both are exchanging the hello packet, and it is sent with the hello packets are exchanged through the local IP address. It is using the local IP address, not the global IP. Link local IP is used for exchanging the packets, ospf hello packets between the two routers. That's the thing. And if you want, I will just start the ping and you can see the response of the ping from the capture. Let me get the router console. Router console is here, R1, and just let me do a ping. Let me do one thing here. You can just put it as a go to the last packet, go to the first packet, go to the previous packet. No colors, automatically scroll last packet, so that it just keeps scrolling. So I will just send a ping and see what happens here. You should be able to capture the packet here. Ping to the this one. See here, you send a ping and IGMP ping and reply request and reply has come. So it's a very good tool. You can even see the captures using a Wireshark. Wireshark is a very good tool for learning purpose. You can do a lot of captures and learn a lot of protocols and other things. Thank you very much for watching. I hope you learned something from this video and you enjoyed it, and we will see in subsequent videos. Thank you very much, and if you need any support you can always mail to the team who will be providing the required necessary support. Thank you.